For 9.2, I decided to go ahead and combine your vocab and read and got it. Vocab's real short on this one. Alrighty, so again, reviewing that idea of graph of a quadratic function. This is the easy way, right? Find the axis of symmetry. We talked about how to do that in the last video. We practiced using that formula to find the x-axis of the axis of symmetry. You find the vertex. That's where we plug that number from the axis of symmetry back into the original equation and solve for y. And then we find the y-intercepts, and we'll do this here in just a second, where x equals 0, and plot the points using the axis of symmetry as a guide. Go ahead and write those down if you wouldn't mind. Just a reminder of some words here. Quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0. Again, where a is not 0, this is the standard form of a quadratic equation. Bring that up because I want that a, b, and c are essential in what we're doing. So we're starting off with that idea of the axis of symmetry again. And I think you've seen this problem from me once before. I just want to go ahead and work it again. So identifying, right, the a, the b, and the c. We only need the a and the b, in fact, for this part. So we know right here's our a, and our b includes the sign that goes with it. So when I find that x, right, x equals, we're going to have the negative, or the opposite of negative 20, because negative 20 is our b, over 2 times a, and a is 5. And when we solve that, we end up with the number 2. So again, that means in this case, this equation right here, that 2 right here, x equals 2, is our axis of symmetry. Right through there. Now again, we'll go one step further and find the minimum in this case, because it opens upwards, so find the minimum. Take that 2 and plug it back into the original equation. So y equals 5 times 2 squared minus 20 times 2 plus 15. And you go back and solve this, and obviously that's negative 5. So y equals negative 5. That means this point right here, right, the lowest point on here, the minimum, is the point 2, negative 5. Okay? Now another crucial step in here is solving when x equals 0 can also give us the y-intercept. And this one is going to be up there a little ways. So and then again using the points like a mirror, right? Plugging in x is 1, x is 2. And using the axis of symmetry like a mirror when you're graphing. Okay, so a little more fun with the idea here of understanding how a parabola works. So so that's y, right, equals negative 16t squared plus 32t plus 4, and these would be the x's. I don't know why they're written like this in the book, but and what we're looking at here is the quadratic function in this form. Y equals ax squared plus bx plus c, so standard form, we can see that right here. The value of b affects the position of the axis of symmetry, so the b right here, and we talked about this before, affects the axis of symmetry. It moves it moves things around, right? So let's look at some examples to get an idea of what happens to that parent function here. So y equals 2x squared plus 2, right here, right? If I change that b, I'm sorry, 2x squared plus 2x. Hopefully I said that right. So we can graph this, right? We can certainly find the minimum, the axis of symmetry, which we just talked about. If I increase that, right? If I increase that b to 4x, notice that slides, right? Slides our axis of symmetry over. Increase it to 6x, right? And again, as it slides it over, it moves our minimum point down as well. And there's a ratio here that b to a, that's what it's related to. So again, noticing here, there's that axis of symmetry, the equation for the axis of symmetry. But again, changing that b moves things as we go. Changing the c does too. We talked about that earlier. And again, we're going to spend a day using Desmos to kind of play with it, see what happens, so we get a feeling of how things change from that y equals x squared, the parent function. Thought it might be better to throw that into a single graph on Desmos for you. You can see I started here with that y equals 2x squared, where the axis of symmetry is the y-axis. Add the plus 2x over and down. Add the plus 4x over and down. Plus 6x over and down. Hey, what's up? Alrighty, so continuing our graphing fun here. So y equals, so this time we're graphing y equals ax squared plus bx, thrown in the c this time. So here we have a is 1, b is negative 6, c is 4. So first thing is, again, find that axis of symmetry, and that is only based on the b and the a. That's why I discussed that before we threw in the c stuff here. The axis of symmetry itself is only based on the b and the a. So obviously axis of symmetry here is going to be 3 right here. Right here, it's going to be 3, so x equals 3. And we can substitute in as well to find the coordinates of the vertex, right? So the minimum here. So plug that 3 into the original equation, solve and get negative 5. So we know our axis of symmetry is x equals 3. The minimum point is 3, negative 5, right down here. That much we've practiced a bit, so. Now, find 2 other points on the graph. So, to do that, again, you get to pick the numbers. It's really up to you what you want to pick for x. And again, you're picking x, not y. So x is 0, x is 4. Or, sorry, y is 4, rather. And again, how do we get that? We plug that 0 back in for x and the original equation, and we find y is 4. And how do I do that so quickly? Well, obviously, if I look up here, if this is 0 and this is 0, the only thing left is the 4. So 0, 4 is certainly a point. So again, we can graph that here, 0, 4. So again, right here, 0, 4. Now, the neat thing is we have an axis of symmetry. And if we head towards, so if we notice that this 0, 4 is 3 to the left of the axis of symmetry, that means there's another point 3 to the right of the axis of symmetry. Hence the name symmetry, right? It's like a mirror. So again, plug in the 0. It's an easy point to find. It's 3 to the left of the axis of symmetry. Go 3 to the right. That's the point 6, 4. Graph that one. And you get to pick another point. It doesn't really matter. In this case, we picked x as 1. Substitute that back in. 1 for x, squared here, obviously. 1 for x here. Solve, and we find that it is negative 1. So the point 1, negative 1 is also on our graph. 1, negative 1. Again, I get 2 points out of the deal because notice that is 2 to the left of the axis of symmetry. So I get 2 to the right of the axis of symmetry. And the point is 5, negative 1. Now again, this works well. You get to pick the points, so don't pick things that are insane. Don't pick 100 or things like that. So now I have 5 points. 1, 2, 3, 4, 5 points. And all I do is draw a nice curve that covers all 5 of those points. There's no straight lines here. There's no V. Nice and even. Okay, so we're going to do a complete problem here with you here. First off, we have to think about this equation. Y equals negative x squared plus 4x minus 2. And first off, we know because a is negative, it's going to open down. We've had that discussion, right? Okay, we also know that negative, again, the 4x is going to adjust the axis of symmetry off, right? It's not going to be the y-axis, that sort of thing. Now then, let's go ahead and get some points, shall we? Before we do anything, we need the axis of symmetry. And we know that what that looks like, the axis of symmetry, is the formula x equals, oops, there we go, x equals the opposite of b over 2. And I say the opposite of b because what if b is negative, right? It's not in this case, but. So that means we're going to get negative 4, because b is 4, over 2 times, and a is negative 1, which, by the way, is the number 2. Okay? Now I plug that back into my original equation for x up here. So that looks like y equals negative, and notice the 2 squared, not the negative, plus 4 times 2 minus 2, which, by the way, is the number 2. So that means that my vertex, so first I'm going to go back, I'm going to draw that axis of symmetry just to make sure that we remember how to use that. There we go. And then we know the vertex is going to be the point 2, 2, right there. The best I can draw on top of the computer here, but you get the idea. So again, this point is the point 2, 2. Now it's time to find some points. I'm just going to make a short chart here. X and Y. I'm going to put in 0. And I'm putting 0 in because I want that y-intercept. It's an easy one to get. So I plug 0 into the original. Obviously, when both x's are 0, I'm going to get -2. So I get the point 0, -2 right here. Now this is where I use that axis of symmetry to my benefit. I am 2 to the left of the axis of symmetry, so I need to be 2 to the right of the axis of symmetry, right there. So I get 2 points out of the deal. And again, what is that point? Well, that other point is the point 4, -2, obviously. Okay, keep going. You get to pick another point. I'm going to pick 3 this time. So I plug 3 back into here. And again, I'm assuming by now we can certainly handle the math. That's the point 3, 1. So 3, 1, 2, 3, right? 1, which is right here. There we go. And again, use that axis of symmetry to our benefit. It's 1 to the right, so I go 1 to the left. Right there, which is the point 1, 1. Now I literally have my 5 points. I have my vertex, my y-intercept and its reflection, right? And the point 3, 1 and its reflection. And then we just graph a nice gradual curve to cover all 5 points. That's all I'm looking for from you when it comes to graphing these. Obviously, that's one example here. I did one before that was from the book. I will do as many as you want in class. I'll graph them all up there if you need me to. Not a problem. I'm going to make you do the algebra work behind it, but we'll happily help you graph them all. Part B of this asks us, so in step 2, problem 1, why would you think it useful to use the y-intercept at one point on the graph? It's any number of things you could say this, but x equals 0 is just an easy point to pick because it automatically yields literally just that c. When the two x's are 0, it yields just the c, in this case -2, without really any work. And I'm about the easy stuff, so